Hello everyone. Welcome to the Syed School. Today, we will learn about VLANs, virtual LANs. What is a VLAN? VLANs, virtual local area networks, are logical divisions of a physical network. They allow you to segment a network into multiple virtual networks, each with its own broadcast domain. This means that devices within a VLAN can only communicate with other devices in the same VLAN. Let's look at this picture. We see that we need two broadcast domains, and devices in the two LANs must not communicate without any link. And broadcasts of one LAN must not be broadcasted to the other LAN. However, if we implement VLAN here, we can reduce the cost of one switch and make the two LANs in one switch, and so the name, virtual LAN. We can see here that we have implemented the VLAN here, and the same thing has been achieved, reducing the switch cost. Why VLANs? VLANs, virtual local area networks, are essential for modern network design due to the following reasons. Enhanced security. VLANs provide a way to segment a network into multiple virtual networks, each with its own broadcast domain. This helps isolate different groups of devices, preventing unauthorized access and limiting the spread of malware. Improved performance. By limiting broadcast traffic to specific VLANs, VLANs can reduce network congestion and improve overall performance. This is particularly beneficial in larger networks or when dealing with bandwidth-intensive applications. Flexibility. VLANs offer flexibility in network design, allowing you to create different network segments based on departmental, functional, or security requirements. This makes it easier to manage and scale your network as your needs change. Simplified management. VLANs provide a logical way to organize and manage network devices. By grouping devices based on their function or location, network administrators can more easily manage and troubleshoot network issues. Cost-effective. VLANs can help reduce the need for additional physical network infrastructure, making them a cost-effective solution. In summary, VLANs provide a valuable tool for enhancing network security, improving performance, increasing flexibility, simplifying management, and reducing costs. Let's take a look at this topology. We see that we need to create VLAN 2 here. After creating VLAN 2 and adding devices to it, we will confirm that different VLAN devices could not communicate with each other in default configuration. VLAN 1 is the default VLAN in a switch in which all the ports are available in default configuration. VLAN 1 is called the native VLAN unless native VLAN configuration is changed. Let's try to ping the devices and see if they are able to communicate before creating a VLAN. Let's go to the command prompt of host 1. We can see that the IP address is 192.168.1.1. Let's go to the host 6 command prompt. Here is the command to assign an IP address from command prompt. I have assigned an IP address here which is 192.168.1.6. All the hosts are in the same network as of now, which is 192.168.1.0. Usually, we use different network ID for different VLANs. Now, let's try to ping host 1. We see that we are getting a reply from host 1 now. Now, let's create VLAN 2 and add host 4, 5, and 6 to it. Let's go to the switch CLI and enter enable mode to check the interface's status. We can see that all the ports are in VLAN 1, which is the native VLAN of this switch. I have added the description to the ports according to the hosts in our topology. Now, let's go into the configuration mode to create a VLAN 2. VLAN is the command to create a VLAN. 2 is the VLAN number. Name is the command to give a name to VLAN. Let's give the name as sales. We see that VLAN 2 is created. Let's see the interface's status again, however, no interface is in VLAN 2 as of now. Let's add the interfaces to the VLAN 2. Let's go to the configuration mode of the interfaces. I would like to add the host 4, 5, and 6 to VLAN 2. So, let's select the respective interfaces. With this command, we can configure a range of interfaces at once. I am configuring F0, 4 to 6. This is the command to add the interfaces to a particular VLAN. Now, let's see the interface's status. We can see that the ports 4, 5, and 6 are in VLAN 2 now. The other ports are still in the native VLAN. Now, let's go to host 6 and see if we are able to communicate with host 1 as both are in different broadcast domain now. We can see that the request is timed out as there is no reply from host 1. We deduce that the different VLANs are in separate broadcast domain. Now, let's go back to the switch and use a different command to check the VLANs in the switch. We see the VLANs here and the ports belonging to the respective VLAN. Now, let's create a VLAN without creating a VLAN. I mean, if we add the ports to a VLAN using switch port access command prior to creating a VLAN, then the switch automatically creates a VLAN for us. Switch gives the default name to that VLAN. Let me add the ports 7, 8, and 9 to VLAN 3 without even creating it. We see that the switch says that VLAN 3 does not exist and create it. Let's use the command show VLAN brief to check if the VLAN 3 is created and what default name does switch gives to it.